Assalamualaikum and hi panels. My name is Aini Wahidah Binti Razali. Today I will be showing you a demonstration video of my project by the title of the development of air ventilation system for temperature controller in a building. But before that, let me tell you a bit of my project. In an enclosed room, a centralized ventilation such as fan or air conditioning system is used to pump hot or cool air throughout the room. However, the problem happens when the system function is uncontrolled and must be manually turned on and off the fan. Sometimes, this situation can lead to high usage of electricity and energy, which in turn will raise the electricity bills and cause energy wastage. As a solution, a system was implemented so that to detect and monitor current room temperature in real time and produce the suitable fan speed in accordance to users' comfortability by using fuzzy logic. For this project, I am using both software and hardware tools to develop this system. As for the hardware, I am using the HT11 as temperature sensor, Node MCU ESP32 as its microcontroller with fuzzy logic library, and LCD display to display the information. For the software, I am using Arduino IDE to construct the program and also MATLAB fuzzy logic toolbox for the simulation test. For the web app monitoring part, I am using ThinkSpeak, an analytics IoT platform, to display the system information for monitoring purpose. This is the board diagram of the system consisting of input part, fuzzy part, and output part. The fuzzy method that I'm using in this system is Mamdani technique, which uses min-max composition for its fuzzification and centroid for its defuzzification part. For the inference rules, I am using if-then directive. This is the prototype of the system. The system starts with DHT11. It will detect the current room temperature. After receiving the temperature, it will send the data to the cloud to be monitored. LCD is used to display the temperature and also the speed of fan in pulse width modulation. The DC fan will rotate based on the fuzzified output that has been given by the microcontroller. For MATLAB simulation test, the membership functions for room temperature and speed of fan are as shown. Both membership functions use trapezium shape. The classification of room temperature membership function consists of 5 fuzzy sets, which are very cool, cold, medium, hot, and very hot. The membership function for speed of fan is represented in PWM. The classification of speed of fan membership functions consists of 5 fuzzy sets, which are very slow, slow, average, fast, and very fast. So let's test our system. So this temperature sensor will detect the temperature, and as you can see, the fan is not rotating because I do not give any power supply to the system. Now let's give power supply to the system. And as you can see, the fan is rotating based on the PWM that is given by the microcontroller. And let's see the current temperature at that time. So the current temperature at that time is 27.10, and based on the fuzzified input, it will give the speed of the fan 191.91. Now let us see the increment of the fan speed based on the increment of the temperature. Here I give the heat to the temperature sensor, and as you can see here, the temperature is increasing, so does the PWM of the fan. Let's give more heat, and you can see here the temperature is increasing rapidly, so does the PWM of the fan. Let's give one more time. Okay, so 42.5. So let's check our web monitoring part. Let us take one value. The value I took at that time is 26.8. So let's see at that time the value is 26.8 and the current temperature will also display 26.8. The current temperature will display at every 10 seconds. So after 10 seconds it will record its new current temperature. Let's take another value. So at that time the temperature is 26.9, the same as ThinkSpeak. This project has some limitations. The limitations are that this fan cannot be remotely controlled, and in terms of its performance, the system needs to be further optimized in the future so as to give more accurate output. The conclusion, this system was successfully implemented on microcontroller with the capability of displaying its monitoring system by using fuzzy logic approach. And that is all from me. Thank you for listening.